Imagine this. Thousands of years ago, in ancient Greece, long before power plants, light bulbs, or cell phones, a curious philosopher rubbed a piece of amber with fur, and something strange happened. Tiny objects like feathers and dust began to move as if by magic. That philosopher was Thales of Miletus, around 600 BC, and what he had just witnessed was the very beginning of what we now call electricity. It was a simple observation, but it sparked a revolution that would take over 2 millennia to unfold. Before we dive deeper into this electrifying story, do me a quick favor. Hit that like button and subscribe, and make sure you turn on notifications so you don't have to miss any of our upcoming deep dives into the science and history that shaped our world. So let's get back to it. In ancient times, people didn't understand what this force was. They didn't have the words for it. They simply called it electron, which is the Greek word for amber. And right there, that's where the term electricity comes from. But it would take more than 2,000 years before humanity could truly understand and control this mysterious power. For centuries, it remained a curiosity, a parlor trick, a strange property of a single beautiful material. Fast forward to the 17th century. The Renaissance had reignited a passion for science across Europe. A man named William Gilbert, who happened to be the personal physician to Queen Elizabeth I, began to meticulously study magnetic forces. He was fascinated by how a compass needle always pointed north, and his curiosity led him to experiment with other materials. He was the first person to use the Latin word, electricus, to describe the kind of attraction he saw when rubbing various substances together, just like Thales did with amber. He was creating a new language for a new science. From that point on, the spark of curiosity spread like wildfire across the continent. By the 18th century, the pace of discovery was accelerating. And this is where one of the most famous and dangerous experiments in scientific history comes in. You've probably heard of him, Benjamin Franklin. In 1752, Franklin famously flew a kite during a thunderstorm, with a metal key attached to the string. His goal was to prove a radical idea, that the spectacular, terrifying power of lightning and the subtle static charge from amber were one and the same. It was an incredibly risky experiment that nearly cost him his life, but his success changed science forever. He had connected the heavens to the earth, proving that electricity was a fundamental force of nature. If you're finding this as fascinating as I do, take just a second to like this video. It really helps our channel bring more stories like this to curious minds all around the world. Now that we knew what electricity was, the next question was, could we create it on demand? The answer came from an unexpected source, a laboratory filled with frogs. In the late 1700s, an Italian physician named Luigi Galvani was dissecting a frog when he noticed its legs twitched whenever they were touched by 2 different types of metal. He called this animal electricity, believing the energy came from the frog itself. He was partially right, but another scientist, Alessandro Volta, suspected something else was at play. Volta realized the electricity wasn't coming from the frog, but from the chemical reaction between the 2 different metals and the moist tissue of the frog's leg. This insight led him to create one of the most important inventions in human history. In the year 1800, Alessandro Volta stacked discs of zinc and copper, separated by saltwater-soaked cardboard, and created the first-ever electric battery, the Voltaic pile. For the first time, humanity had a steady, continuous source of electric current. And yes, that's exactly where we get the word volt to measure electric potential. Electricity now had a source, but it was still a wild force. It needed to be tamed, to be controlled, to be put to work. Enter Michael Faraday, a self-taught genius who rose from humble beginnings to become one of the greatest scientists in history. In 1831, Faraday made a monumental discovery, electromagnetic induction. He found that moving a magnet through a coil of wire could generate an electric current. This might sound simple, but its implications were world-changing. This was the principle behind the electric generator. Faraday had unlocked the secret to converting motion into electricity on a massive scale, a discovery that would literally power the entire industrial world. And if you're still here with me, you're a part of a special group of people who truly appreciate how far we've come on this journey. So go ahead and subscribe now and press that bell icon, because the story is about to get even more electrifying. The 19th century became an age of scientific giants, and at the heart of the electrical revolution were two men with brilliant minds and fiercely different visions for the future: Thomas Edison and Nikola Tesla. Edison, the relentless inventor and shrewd businessman, championed direct current, or DC. It was simple, easy to generate, and worked well over short distances. He used it to light up parts of New York City, creating a spectacle that amazed the world. But Nikola Tesla, a visionary genius, saw the limitations of DC. He knew it couldn't travel far without losing power. Instead, he championed alternating current, or AC, a system that could be easily stepped up to high voltages for long-distance transmission and then stepped down for safe use in homes and factories. Their rivalry became known as the War of the Currents, a dramatic battle of technology, public relations, and finance that shaped the very foundation of our modern power infrastructure. Ultimately, Tesla's AC system won out for its efficiency and scalability. Today, the systems that light your home, power your appliances, and charge your phone trace their roots directly back to that historic conflict. But the journey didn't stop there. Once tamed, electricity became the foundation for every single major technological revolution of the 20th and 21st centuries. It powered the telegraph, connecting continents in an instant. It gave birth to radio waves, allowing voices to travel through the air. It became the lifeblood of the first computers, massive machines that filled entire rooms. And it led to the invention of the transistor and the microchip, shrinking the world of computing onto a tiny piece of silicon. Think about it for a moment. The very same mysterious force that made a piece of amber attract dust 2,600 years ago is now powering the supercomputers that model our climate, the rockets that take us to space, the global servers that hold all human knowledge, and even the very device you are using to watch this video right now. So, the next time you flip a light switch, plug in your phone, or turn on your computer, take a second to remember the long and incredible journey of that invisible power. You're not just completing a circuit. You're touching the result of millennia of human curiosity, relentless experimentation, and unparalleled brilliance. You're connecting to a legacy that began with Thales, was proven by Franklin, was harnessed by Volta and Faraday, and was unleashed upon the world by Tesla and Edison. If you learned something new and inspiring today, do us a huge favor and smash that like button, subscribe to the channel, and ring that notification bell, because we are just getting started. The story of human progress is powered by one thing: energy. We'll explore more of it together. Thanks for watching, and we'll see you in the next video.